Hello. Whenever you talk about a wire, electrical wire, and through the electrical wire current is flowing. When the current is flowing, what happens? What happens? The one thing is that wire becomes hot. Whenever the current flows through the wire becomes hot. That is the one thing everybody knows that. That is nothing but heating effect of electric current. But when the current is flowing through the wire, one more thing is happening. What is that? That is a magnetic field is produced all around the wire. So, how to find the value of this magnetic field? So, magnitude of the magnetic field. How to find that? On what factors the magnetic field is depending upon? So, that can be obtained easily by using a law called Biot Savart law. In today's video, I am going to talk about what is Biot Savart law. Suppose it is an electrical wire, and from this electrical wire some current is flowing. What direction the current is flowing, that I will not discuss now. The current is flowing in a particular direction. When the current is flowing, what will happen? The magnetic field is produced around the wire. So here is a magnetic field is produced. When the magnetic field is produced around the wire, we wish to find out how much magnetic field is produced. You see, whenever you do anything, the first question comes how much. When you purchase something, it is how much. Similarly, when current is flowing, the magnetic field is produced. So the first question comes in the mind, how much magnetic field is produced. So we select a particular point. Suppose I select the point P. So at the point P, you want to find how much magnetic field is produced. So that magnetic field at the point P we can easily obtain by using Biot Savart law. One more thing, when we got a wire and from the wire the current is flowing. When the current is flowing, can we directly find out the magnitude of magnetic induction due to entire wire? No, we cannot find out the total value of magnetic induction value for entire wire directly. We cannot do that. For that we need to select a small part of the wire like this. Here I can select the small part of the wire. By using the small part of the wire, now we will obtain the expression for magnetic induction due to small part of the wire. Then we can extend that formula to the entire part of the wire. For example, you are arranging a party. Suppose 100 persons are coming. So can we directly calculate the cost for the 100 persons? No. First we have to calculate the cost for the one person, then multiply it with the 100, then you will get the entire cost for the 100 persons. Similarly here we cannot calculate the magnetic field directly for the entire part of the wire. First we have to take a small part of the wire, then obtain the expression for magnetic induction for that small part of the wire. Then you can extend that formula to the entire part of the wire. For that, here I have selected the small length, very small length. We call it a small element of the wire. So that small length is called small element. So let us call this small element as a DL. So this is the length DL we selected here because it is quite small. Therefore we call it as a DL. Now current is flowing through the DL. Current I is flowing through the small element DL, and the magnetic field produced all around it. So let us select a particular point. Let us say this is the particular point P here. So why I selected here, I can select within the region of influence. You cannot select somewhere like this. Wire is here and you are after 3 meters you are selecting the point. That will not work. You have to select the point such that the magnetic field is easily realized by the compass needle. Compass needle will show the deflection. Within that region you have to select the point P. So let us select the point P here and now join the center of the element to the point P. So this is the way we have selected the center of the point element to the point P. Now the magnetic induction depends upon length DL, the elemental length of DL. So if you double the length, suppose I select the DL, now DL. So what is the length? Length AB equals to DL plus DL. The length has become twice. So my question is that, will the magnetic induction will also increase? Answer is yes. When the length of the wire increases, then magnetic induction value also increases. So according to Biot Savart law, the magnitude of magnetic induction will be depending upon the length of the wire. As the length of the wire increases, the value of magnetic induction also increases. So magnetic induction, the magnitude of magnetic induction directly proportional to length of the element AB. As the length of element AB increases, then the value of magnetic induction also increases. So this is the first factor. This is the first factor of Biot Savart law. In the statement of Biot Savart law, the first factor is that the magnetic induction directly proportional to length of the element dl. Now, second thing is current. If I increase the value of the current, here the current is how much? I. Now, if I increase for current I, what is the magnetic induction? dB. Now, if I increase the value of the current, suppose I double the current here, will the magnetic induction will increase? Yes. As the value of the current increases, the value of magnetic induction also increases. So the current, the second factor is that dB directly proportional to magnitude of the current. Now one more thing, here was the point P and this is the angle between what? Angle between DL and let us call this point as a O. This is the O, OP. So angle between DL and OP is equals to theta. So if theta is changing, then magnetic induction will also change. So the magnetic induction depends upon value of theta. If the theta is changing, then the magnetic induction will also changing. That we take the sine theta here. So the value of, according to Biot Savart law, it is telling that the value of magnetic induction at the point P will depend upon theta, that is directly proportional to sine theta, because sine 0 equals to 0, sine 30 equals to 1 by 2, sine 45 equals to 1 upon root 2 and sine 90 equals to 1. That means as the theta increasing, the value of sine theta is also increasing. So here, according to Biot Savart law, the value of magnetic induction depends upon the value of sine theta. As the sine theta increases, the value of magnetic induction also increases. That means the smallest value of magnetic induction is for theta equals to 0 degree. When theta equals to 0, everything is 0. And when theta equals to 90 degrees, you will find the maximum value of magnetic induction at the point P. So the magnetic induction will, the value of magnetic induction will depend upon the sine theta. So dB directly proportional to sine theta. Now one more point, that point P was placed here, and let us call this distance, that is the OP. Length OP is equals to, let us say, 1 meter. Now we will extend little bit the distance. Suppose this is let us say 0.5 meter. Now so another point P1, that is 0.5 meter. Now another point, let us say further we increase 0.5 meter, that means so P1 is at a distance of 1.5 and let us say P2 at a distance of 2 meters. So what is the length OP? Length OP nothing but 1 meter, and length OP1 equals to 1.5 meter, and length OP2 equals to 2 meter. I selected meter here to make you understand. It may not be meter, it may be centimeter, or it may be mm. But to make you understand, I just selected here the meter. So which point is very close to the DL? The point P is very close to the DL. That means it is near to the element DL. When the point is near to the element DL, there is a magnetic induction is larger. As you are moving away from the element DL, the value of magnetic induction also decreases. Not only decreases, but decreases with a larger amount. Okay, so we can say that the magnetic induction inversely proportional to square of the distance between the point P and the point O. O is selected at the center of DL. So the magnetic induction is inversely proportional to square of the distance of the point P. As the distance increases, the value of magnetic induction will decrease. So these are the 4 factors will decide the value of magnetic induction at the point P. Now let us summarize all the 4 points. So we had first dB directly proportional to I, and dB directly proportional to dl, and dB directly proportional to sine theta, and dB inversely proportional to square of distance, that is length OP. This distance is equals to R. R is changing, then value of the magnetic induction is also changing. So these are the 4 factors. Now we will combine all 4 factors to make one single equation. What is that? dB directly proportional to I dl sine theta upon R square. Now to remove this proportionality symbol, we create here a constant. We introduce a constant here. So dB is equals to K. K is a constant of proportionality. So K into I dl sine theta upon R square. K is the constant of proportionality. Now K will depends upon the 2 things. One is a system of measurement, that what type of system you are using. Are you using CGS system, MK system, SI system? What type of system you are using? On that system, the value of K depends upon. The value of the K also depends upon medium where the point P is situated. What is the medium between the conductor and the point P? So where you have placed it? Have you placed in the water? Have you placed in the gas? Have you placed in some other magnetic material? Where did you place this point P? So the point P plays in certain medium. So the magnetic induction will depend upon the permeability of the medium. As the medium is changing, the value of the K is also changing. But now we just make it simple. We assume that the point P is placed in the vacuum or air or a free space. So what is the K value? The K value is nothing but mu naught upon 4 pi. What is mu naught? Mu naught nothing but permeability of free space. Permeability of free space. And what is the value of mu naught? The value of mu naught nothing but 4 pi into 10 raised to minus 7 Weber per ampere meter. So that is the SI system. Under the SI system, the value of mu naught is 4 pi into 10 raised to minus 7 Weber per ampere meter. Therefore, Therefore, what we can write here? dB equals to k value. What is the k value? Mu naught upon 4 pi multiplied by I dl sin theta upon r square. Now here mu naught value nothing but 4 pi into 10 raised to minus 7. So therefore dB equals to 4 pi into 10 raised to minus 7 divided by 4 pi into I dl sin theta upon r square. 4 pi will cancel. So we get dB equals to 10 raised to minus 7 I dl sin theta upon r square. Now we even can discuss the Biot Savart law in the vector form. Till now what we developed is the scalar form. How you came to know that was a scalar form? Because in the previous discussion till now we have not talked anything about the direction. We did not talk about any vectors, what direction, etc. So when we don't talk about the direction, it is a scalar form. Why to talk vector form? You see, whenever we are using any kind of machine, we are passing the electrical current and the magnetic field is produced. When the magnetic field is produced, what direction the magnetic field is produced is important. So to find out the direction, what direction the magnetic field is produced, we need to convert the scalar form into the vector form. Once you convert them into vector form, then you can easily find out what is the direction, what direction the body is moving. So here we are going to get the vector form now. We are going to convert the scalar form to vector form of the Biot Savart law. How is that? Let us see. Now here is the current flowing through the small element AB is di. I is the current is flowing and the length of the small element is dl. So I dl. So current multiplied by small element. So I dl is nothing but called current element. It is called current element and it is a vector quantity. Therefore I dl is a vector quantity. Here I have kept the arrow mark. So current element is a vector quantity. One more thing that we know that vector A cross B is nothing but AB sin theta. Now if you write reverse, if AB sin theta given, if you wish to write in the vector form, how will you write? Vector A cross vector B, like that. Suppose you are given IDL R sin theta. Suppose IDL R sin theta. How will you write? You will write IDL. IDL is already a vector quantity. Cross R is already vector quantity because I told you that OP is a vector. So here I can write vector R. Now in this equation, let us call it equation 1 and 2. Now in equation 1, what is the problem? There is no R. R is absent. So to create the R there, what we can do? We can multiply divide by R there. So there is shortage of R. To create the R here, what we do now here? dB is equal to mu naught upon 4 pi. Here is I dl sin theta and already R square is there. Now multiplying and dividing by R. So dB equals to mu naught upon 4 pi. Now taking that R inside. So I dl R multiplied by sin theta and R square into R equals to R cube. Now call it as the equation number 3. Now from equation 2, I dl r sin theta can be written as I dl vector I dl cross r. So we are converting the equation 3 in terms of vector. So left side also the vector will come. The dB will also get converted into vector. So vector form is vector dB equals to mu naught upon 4 pi and I dl r sin theta writing in the terms of vector. So that is I dl vector cross vector r divided by r cube. Now this equation 4 is called vector form of Biot Savart law. Now I want to find the net magnetic field due to entire wire. In the beginning I told you that if you are arranging a party, you want to give party to the 100 people, then you will calculate cost of one person, then multiply to 100. Now we already calculated the cost of one person here. The equation 4 is giving you cost of 1%. That means magnetic field developed by the single element. But this wire is made up of large number of single element. So at the point P, there is a magnetic field due to all small such elements. So the entire wire is divided into small elements, equally divided into small elements. Now we want to find out the total magnetic field at the point P. So how to find the total magnetic field at the point P? For that, what we do? We take summation, that is summation dB, okay, is equals to summation mu naught upon 4 pi here I dl vector I dl cross vector r divided by r cube. Now let summation dB equals to b, vector b. Therefore vector b, and here constant mu naught upon 4 pi is the constant, take it out from the summation. So summation we got here, and here I dl cross r divided by r cube. By using this formula, we can find out the total magnetic field at the point P. Call it as equation 5. Now here equation 5 is not totally correct. Why it is not totally correct? The reason is that how small the element dl is, that is not mentioned in the equation 5. To mention that, what you do? Vector b equals to mu naught upon 4 pi, and here is a summation, and what is the length of dl is not mentioned. So dl is a very small element. Whenever you got a wire, we said this is the dl. So what is the length of the dl? The length of dl is very, very small. How much small it is? It is near about 0 but not equal to 0. To mention that, what you do? Limit dl tending to 0. Now the equation 5 becomes perfect. I dl cross r divided by r cube. By using this expression, we can find out the resultant magnetic field due to entire wire, entire element, entire conductor. So that is b equals to vector b equals to mu naught upon 4 pi summation and limit delta l dl tending to 0 I dl cross r upon r cube. Now the same equation in the integration form. The same equation we can write in the integration form, that is mu naught upon 4 pi integration, here is the integration, and I dl cross r divided by r cube. By using this relationship, we can also find out the vector b here. So this is the integration form. So this way we can find out resultant magnetic induction at a point due to the entire given conductor when the current I is flowing through the conductor. And this is nothing but Biot Savart law. And this expression, all these expressions, different expressions, They stand for Biot Savart law. By using this, you can find out how much magnetic field due to a current element. For example, a circular wire. From the circular wire, current is flowing. Then it will produce the magnetic field at the center. So that can be easily obtained by using the Biot Savart law. It is quite useful law to find the magnetic induction. That's all about Biot Savart law in the scalar and vector form. I hope now you are clear with the concept of Biot Savart law, the magnetic induction at a given point due to the current carrying element. Still you have some doubts in your mind, please communicate your doubts, your difficulties on my email address provided in the description box. Meet you again with another topic. Till then, wish you good luck, all the best. Before saying goodbye, I would like to request you like, share and subscribe the channel so that you will keep on getting the latest videos published based upon the physics. Bye bye. Wish you good luck, all the best.